9.2 is all about simplifying rational expressions. The only difference between a rational expression and a rational function is that an expression is not set equal to anything. We just don't have the equals 0 or equals y. So it's just the expression. As we go through this, you'll notice that these rational expressions are basically polynomial divisions. So this is going to be very similar to what we did in Unit 4. Key terms for this one is that a rational expression is just an algebraic fraction whose numerator and denominator are both polynomials. Like I said, very similar to Unit 4. Since division by 0 is undefined, the polynomial in the denominator cannot be 0. So, let's look over some of these. Example 1 and 2, we are looking for the excluded values for each rational expression. Now remember, we just need this denominator to not equal 0. We cannot have a 0 denominator because you can't divide by 0. So what is the only number that would make this thing 0? Well, that would be if n is equal to 0. Okay, the only time where we get 18 times some number squared to be 0 is if n were 0. So that's the only number that we can't have in this polynomial function or in this rational expression. So for these ones, again, we're just simply stating what numbers we can't have. On this example, though, again, we want it so that this denominator cannot be equal to 0. Now this one is not as easy to notice right away what v cannot be. So to make it easier on ourselves, we can factor this out. Now it's always best to first look for the greatest common factor. So if we have 2v squared minus 2v, we can take 2v as the greatest common factor out of that, and it would leave v minus 1. Because 2v times v is 2v squared. 2v times negative 1 is negative 2v. Now looking at our polynomial here, if we set it equal to 0 on bottom, we've got two things being multiplied, a 2v and a v minus 1, and they have to equal 0. Well, if we wanted 2v to say 0, or to not say 0, I guess, we'd say v cannot equal 0, because that would make this part 0. What would make this part 0? If v was 1. So v cannot equal 0 or 1. These are the excluded values, because if you plugged 0 or 1 into this expression, you'd be dividing by 0, and we can't do that. Simplifying expressions. A rational expression is in its simplest form when the numerator and denominator have no common factors except for 1. To simplify a rational expression, factor both the numerator and the denominator, and then divide out any common factors. So let's see what that means here. In kind of a general term, if you've got b times a over c times a, you could break that up into kind of your separated parts here, b times a, c times a. Well, this a is going to cancel out from top and bottom. You just be left with b over c. I'm going to do another example of that using just numbers. So if we have 12 over 8, well, that's the same as 4 times 3, because that's 12, and 4 times 2, because that's 8. Now we can cancel out the 4's. We'd say 12 over 8 is the same as whatever's left over here, 3 over 2. Just like how we'd simplify a fraction like this by breaking it up into its factors and then canceling those out, that's how we would simplify our rational expressions. So here's an example using those polynomials. So if we have 3x minus 9 over 4x minus 12, we can factor each of those pieces, take out a greatest common factor, 3 in this case, and x minus 3, and then 4 in this case, and x minus 3. We'll notice this binomial, x minus 3, happens in both cases, so we can cross it out, and we'd just be left with 3/4. So 3x minus 9 over 4x minus 12 simplifies to 3 over 4. So that's what we'll be doing with simplifying each of these expressions. So for example 3, we've got 15a cubed over 21a. Now there's two ways we can do this. We can factor out the whole monomial on top, or the whole piece on top. So again, really similar to Unit 4. 15 is the same as 3 times 5. A cubed is times A times A times A. All over 21A is 3, oops, make that look like 3 times 7 times A. Then we can say 3 cancels out with 3, A cancels out with A. What's left over? 5A squared over 7. So that's one way we can do it. Okay, we can factor the whole thing out and just cancel pieces individually. Or, if we're pretty good with our factors or fractions, 15 over 21 is the same as 5 over 7, a to the third and a to the first. Remember from, again, polynomial division, we'd have to subtract this one from the bottom from this one on top, and we'd be left with a to the second. Either way, we get 5a squared over 7. Both ways will work. So if you like factoring it out this way, go ahead. If you can remember your rules from polynomial division, go ahead and use that. Let's look at example 4 now. We've got a negative on the outside, which again basically means we're just multiplying by -1. So if it makes it easier for you, I want you to kind of eliminate that and just say -1 on top times 6k. That way we've kind of dealt with our -1 piece. So if we want to break this up into all of its factors first, -1 times 2 times 3, because 2 times 3 is 6, times k, all over 27 is 3 times 3, which is 9, times 3, which is 27, times k times k. Then, like before, 3 and 3, k and k. What are we left with? -2 on top over 3 times 3 times k, 9k. So again, we can factor it all out and just simply cross out factors. Or, again, if we notice k to the first here and k to the 2 here, means that it's going to be k to the 1 on bottom. We take this one away and 1 away from here, so it's left down here. 6 over 27, divide 3 out of each of those, and we're left with 2 over 9. And then the -1 still applied to the top. So it'd be -2 over 9k. Again, either way, you can factor it all out, or just remember your rules from polynomial division. All right, now note, when we determine the excluded values, we'll always use the original expression from factored form rather than the simplified expression. The simplified expression crosses out some of our excluded values. So we want to make sure we find the excluded values before we cross anything out. Now when we're factoring, remember, always check for the greatest common factor. That's step number 1 for factoring, is greatest common factor. Then you check for how many terms. 2 terms is we look for difference of squares. 3 terms is we look for the AC. And 4 terms we look for grouping. So let's look at example 5. First off, we need to state the excluded values and simplify each. So we need to factor the top and the bottom, use the factored form to find excluded values, and then simplify. In this case, on bottom, we want that to say, or again, to be not equal to 0 to find an excluded value. So we need to factor this. This has 3 terms, so we use the AC method. A is 1, C is 24, so AC is 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. 24 is positive, right here. So they're either both positive or both negative. We need them to add up to -10, so that's going to be -4 and -6. Rewriting just that bottom piece, we split up the -10 into -4x and -6x. Factor by grouping this piece and this piece. X on the outside times x minus 4, -6 on the outside times x minus 4. So when we put it all together, we have an x minus 4 times this factor, x minus 6. Now this was just the bottom. Remember, we still have to include that piece on top, that, oops, in parentheses, x minus 4. I know it didn't have a parentheses before, but it might be easier to put parentheses on there so you can see that that is one factor itself. That is one piece. It's like saying that times 1. So, using this is kind of our simplified or factored expression. Now we can say, all right, our excluded values, using this and this, we know for sure that x cannot be 4 and x cannot be 6. So those are our excluded values. But to simplify the expression fully, we have an x minus 4 and an x minus 4. We can cross those out and say our simplified expression is 1 over x minus 6. We crossed out these factors. Now, our simplified version is 1 over x minus 6. Our excluded values, x cannot be 4 or 6. Even though this one just would say 6, it looks like 6 is the only thing it can't be. We have to remember that this one said x also cannot be 4. So that would be the simplified form and the excluded values. Example 6. Again, always check for greatest common factor. So as we're pulling things out, this top piece we can take a 3 out and we leave r minus 2. This bottom piece only has 2 terms, so we're going to look for difference of squares. R squared minus 2 squared, because 2 squared is 4. Remember, when you can write something as a difference of squares, r to the 2 minus 2 to the 2, you can rewrite it then as r plus 2, r minus 2. Those would be our factors of a difference of squares. Now, using this bottom piece, we can say the excluded values would be r cannot be negative 2, r cannot be positive 2. So here are our excluded values. Looking to simplify this, r minus 2 and r minus 2 means that we're left with 3 over r plus 2. So this would be our simplified form. These would be our excluded values. Example 7. Again, always check for greatest common factor. We've got 2 different trinomials. Each of them has an a value of 1. Now I want to look back at this one really quick, example 5. Notice that when a was 1, there's nothing out in front of it, our factors, negative 4 and negative 6, ended up being these factors, x minus 4 and x minus 6. This happens every single time as long as a is 1. If the a value is 1, you're simply just saying x minus 4, x minus 6. So let's use that to our advantage here. In this top piece, a is 1, c is 35, so ac is 35. We've got 1 times 35, 5 times 7. We need it to be a negative 12. That means we're looking at negative 5 and negative 7. So these are going to be our factors. Now we don't need to break it up into 4 terms. We would just know that k minus 5 and k minus 7 are going to be our factors. Those are our shortcuts whenever a is equal to 1. For the bottom piece, again, a is equal to 1, c is negative 21. So ac, we're using 21. Remember though, in the back of your mind, think of it as a negative. So we need 1 negative and 1 positive, and they have to add up to negative 4. So that would be 3 and negative 7. Again, this one is positive, this one's negative. So our terms would be, or our factors would be k plus 3 and k minus 7. We just use these exact factors because our a value is 1. That'll work every time. So here are our factors, or here is our factored form. From there we can say, looking at our denominator, we know that k cannot be negative 3. Oops. And k cannot be positive 7. Those are our excluded values. To simplify this, we can take out k minus 7 from each piece, and we'd be left over with k minus 5 over k plus 3. So here are our excluded values and our simplified expression. Example 8. Again, always check for greatest common factor. Looking at the top piece, 30m cubed minus 10m squared minus 140m. We can take 10m out of each of those, and we'd be left with 10m as the greatest common factor on the outside. Inside, we are left with 3m squared minus 1m minus 14. Similarly, on bottom, we can take a 10m out of each of those and get 5m squared minus 4m minus 1. Now we're looking at the two trinomials inside the parentheses. In this case, a is not 1, so we have to do the AC method. 3 times 14 becomes 42. And actually, we should write in that it's going to be a negative 42, because we have negative 14 here. So we're looking for two factors of 42, one positive and one negative, so that they'll add up to negative 1. Well, 1 and 42 are 41 apart. 2 and 21 are 19 apart. 3 and 14 are 11 apart. 6 and 7 are 1 apart. Since we want it to be a 1, we have to use 6 and 7. Since we want it to be a negative 1, the bigger number has to be negative. So it has to be negative 7. 6 and negative 7. Similarly, let's look at the bottom one. 5 is our A, negative 1 is our C. So we've got 5 is our AC, and remember, it needs to be negative. And we want it to say negative 4, so that's going to be 1 and negative 5. So we have our two factors, or our two pieces that we need for breaking it up. We break the top one. This negative 1m becomes positive 6m minus 7m. This minus 4m becomes plus 1m and minus 5m. So now we've broken it up into 4 terms. It's ready for factoring by grouping. Here's one group. Here's our other group. That's for on top. On bottom, here's one group. Here's our other group. Now, I'll leave that there. As we factor by grouping, this one we can take 3m out of. This one we can take negative 7 out of. And they'll both leave m plus 2. This one we can take m out of. This one we can take negative 1 out of. And they'll both leave 5m plus 1. Simplifying our top and our bottom, we have 10m is the greatest common factor on both of them on the outside. Inside on top, it leaves m plus 2 times 3m minus 7. And you can see the red ones were the m plus 2. Then we have a 3m and a minus 7. On bottom, same thing. The red ones were a 5m plus 1. Green ones were an m minus 1. So there they are, with the 10m on the outside still. Using this is our factored form. And we can see that we have 3 different factors. 1, 2, 3. So we'll have 3 excluded terms. For this blue case, if we want this to be 0, again, we're just setting 10m equals 0, we would say that m cannot equal 0. This 5m plus 1 might be a little tricky. So I want you to actually on the side write 5m plus 1 cannot equal 0. Solve for m. Subtract 1 from both sides, and we get 5m equals negative 1. Divide by 5. Divide by 5. Oops, 5. And we'd find out that, oops, this is a can't equal. M cannot equal. You can leave it as a fraction if you want. I'm going to use this one because this one actually looks better. M cannot equal negative 1/5. So if you're having trouble figuring out exactly what it is, actually set it equal to 0 and solve for it. The last one we can see pretty easily is m cannot be positive 1. So here are 3 excluded values. Looking to simplify this, cross out 10m, 10m, and we're left with m plus 2, 3m minus 7, over 5m plus 1 times n minus 1. Last example. Again, always check for greatest common factor. Our first step in this one. These two don't have a greatest common factor, but we do notice them as a difference of squares. 6 squared minus t squared. The bottom one does have a greatest common factor of 5, so we take it out and it's now 5 times t minus 6. Simplifying even more, the top piece becomes 6 minus t and 6 plus t, difference of squares. So we have on the bottom then 5t minus 6. Using that, we know our only excluded value is t cannot equal 6. So that part will take care of all of our excluded values. Now, when we're trying to simplify, none of these match perfectly, but this is about recognizing opposites. If we have a t minus 6 and a 6 minus t, we can factor out something really quick to make them so they do actually match. On the top, just this piece, this factor alone, if we divide out a negative 1, so negative 1 on the outside times what pieces would come back to this? Negative 1 times negative 6, negative 1 times positive t would make this exact factor. So we factor out a negative 1. Now, simplifying that, t plus negative 6, or negative 6 plus t, these can be flip-flopped. As long as there's a plus between them, you can switch their order. So we'll keep our negative 1 on the outside, switch it to t plus negative 6. We just switch these around. Now t plus negative 6 is the same as saying t minus 6. When you're adding on a negative, it's the same as subtracting it. Now we can notice that t minus 6 crosses out with t minus 6. What's left over then? Our simplified expression of negative 1 times 6 plus t all over 5. This would be our simplified expression then. And that'll wrap up 9.2.